Why are infrared spectroscopy, IR, and Raman spectroscopy the most commonly used techniques for analyzing the composition and structure of materials? How does Fourier transform infrared spectroscopy, FTIR, work? And what specific types of molecular vibrations does it primarily analyze? What role do asymmetric vibrations of polar groups play in FTIR analysis? And how do these vibrations provide insight into the molecular structure? Can Davis Surins manufacture solid-state sodium-ion batteries made from seawater in Latvia? How does Raman spectroscopy differ from FTIR? And why is it particularly effective for analyzing the symmetric vibrations of nonpolar groups and molecular skeletons? How can Raman spectroscopy and FTIR spectroscopy complement each other when used together? And what additional information can be gained by employing both techniques? What types of materials, such as organic, inorganic, and metallic materials, can be effectively studied using FTIR and Raman spectroscopy? How do these two techniques help in identifying the structural features and components of various types of cell materials? What specific types of molecular interactions or vibrational modes can be distinguished through the use of FTIR and Raman spectroscopy? And how do these measurements contribute to a deeper understanding of material properties? How do the differences between polar and nonpolar molecular vibrations influence the choice of spectroscopy method for a given material analysis? In what scenarios is it beneficial to use both FTIR and Raman spectroscopy together, and how can it be applied in various scientific and industrial applications? How do FTIR and Raman spectroscopy help scientists and researchers identify the molecular composition, functional groups, and structural arrangements of materials in a non-destructive manner? How can the data from these techniques be used to confirm the identity and purity of substances, or to analyze changes in material composition due to environmental conditions or processing? What is infrared, IR, spectroscopy, and how is it also referred to as molecular vibration rotation spectroscopy? How does IR spectroscopy belong to the broader category of molecular absorption spectroscopy? What happens when a sample is irradiated with IR light that has continuously changing frequencies? And how does the sample interact with this radiation? How does a molecule absorb specific frequencies of IR radiation? And why is this absorption significant in the context of molecular spectroscopy? What role does the vibration or rotation of the molecule play in the absorption process? And how does this result in a change in the dipole moment of the molecule? How does this change in dipole moment relate to the molecule's energy states, and how does it influence the molecule's transition between energy levels?